All right, so if you have three equations with three variables, your goal is to first eliminate one of the variables. So you're going to take a look at these three equations and look at all three variables. So if I look at the x's, if I add or subtract any of the equations, they don't go away quickly. Here I have a negative 5y, a negative 5y, and a positive 5y. So this looks like a good candidate. And the z's, again, don't look like they'd be quite as easily to eliminate. So I'm going to start by eliminating the y's. Now I'm actually going to start with equation 1, the pink equation, and the blue equation. I'm going to put those two together. So if I have minus x minus 5y plus z equals 17. And to that, I'm going to add the equation 2x plus 5y minus 3z equals negative 10. When I add these equations, I'm going to get x. These terms, of course, are going to cancel out. I'll have a minus 2z equals 7. So now I have one equation here that has two variables, and I used equation 1 and equation 2. I have to continue using two other equations in order to also eliminate this y value in order for me to have two equations and two variables. So now I'm going to use the green and the blue equation. So I'm going to say minus 5x minus 5y plus 5z equals 5. 2x plus 5y minus 3z equals negative 10. And now, once again, when I add these equations, I'm going to get minus 3x. These terms cancel out, which is what I needed to happen, plus 2z equals a minus 5. Now here, I have two equations and two variables. So now I'm going to work with those two equations and eliminate one variable. Well, once again, if I look at the variables, the x's don't easily cancel out, but boy, these z's would cancel out very easily. So I'm going to put those two equations together and cancel out the z's. So I'm going to have x minus 2z equals 7 and minus 3x plus 2z equals negative 5. And now when I add those two equations, I'm going to get negative 2x. My z's will cancel out, which is what I wanted to have happen. And this is going to equal a positive 2. Divide by a negative 2. And I'm going to get x equals negative 1. Now that I know that x equals negative 1, I can substitute that negative 1 into either one of these two equations to get what my z value would be. I'm going to pick this one somewhat arbitrarily. So I'm going to have minus 1, because that's my x, minus 2z equals 7. I'm going to add 1 to both sides. I'm going to get minus 2z equals 8. You can see what I'm doing. I'm going to divide by negative 2. I'm going to get z equals, oops, this is negative 2, equals negative 4. So now that I have x and z, now I can go back up to my original equations, and I can put x and z into any one of these three equations and solve for y. I'll pick the pink equation, again, sort of arbitrarily. So I have a negative. My x was negative 1, so I'm going to put that in, negative 1, minus 5y, plus my z value, which was negative 4. And that's going to equal 17. So that's just, whoops, you can't see that, sorry. So I'm just inputting my x and my y value into this pink equation. And so this will be 1 minus 5y minus 4 equals 17. This will be negative 3, so I'm going to add 3 to both sides, and I'll have minus 5y equals 20. And y will equal negative 4. So now you have your x, y, and z values. Sorry about the phone.